Another two classes of systems are continuous time and discrete time systems, analog and digital systems. They are very easy to understand. So these systems are classified based on the input-output signals. Okay. Now let us go inside the video and analyze what are continuous time systems, discrete time systems, analog systems and digital systems.
Continuous time and discrete time systems. It is very easy to understand the continuous time and discrete time systems. Let us start with the definition of a continuous time systems. We can also write CT systems. CT systems. So CT stands for continuous time. A system whose inputs and outputs are continuous time signals. Okay, you have to note that the input and output of the system are continuous time signal. That is why it is represented as x of t and y of t. So what are continuous time signals? That we have already discussed in the second lesson. That is classification of signals. So a system whose inputs and outputs are continuous time signals are called continuous time systems. Normally we use analog devices. Okay, analog devices to process such signals. For example, resistor, capacitor, inductor, then transistor, BJT transistors, diode, all these elements are used to process. Even op-amps are used to process such kind of signals and to get output. So this was the case of previous era of electronics, where we use many of the analog devices to process such kind of signals. But coming to the discrete time systems, otherwise DT systems, it is defined as a system whose inputs and outputs are discrete time signals are called discrete time systems. Here you can see input is x of n and output is y of n. So it is not t, it is n. So what is this discrete time signals? We have already discussed in the second lesson, that is classification of signals. So if you have any confusion, I request you to go back and watch that videos for a better clarity. Right here, the time domain signal, which is varying continuously in time, is discretized. Now we are considering only sample values. Otherwise we can say that some numbers, right, some numbers are going inside this system and that numbers are processed and we are getting some numbers as the output. So this should be a mathematical implementation, mathematical implementations. Okay, mathematical implementation. So unlike the continuous time systems, discrete time systems are implemented using digital arithmetic and logical circuits. An application which contain both CT and DT system is digital filtering. So we know that digital filtering is something which is used to filter out a particular signal of interest, otherwise to remove the noise from the signal, right? So here in this particular application we need both CT systems and DT systems. In real time we know that all the signals are analog signals, right? So all these signals are CT signals. So the CT signals are taken inside, it is converted to discrete, otherwise it is sampling. Actually what is happening here is sampling. What is happening here is sampling, and we get x of n. This is discretized signals, and that is processed inside this discrete time system, which will be normally digital logical circuits to perform some mathematical or logical operations, and we get some y of n. So that is the output samples. So here you can see this is the CT signal, this is the DT signal, converted from the CT signal to DT signal. Now this is the processed output. This is the output. Actually this is the output, processed output. And finally in real life again we need the continuous time signals, because we can hear or listen to only continuous time signals. So this module convert back this y of n signals, that is the discrete time signals, to continuous time signals y of t. So this is one of the best example where we can see the conversion from continuous time domain to discrete time domain takes place, and the processing is happened in the discrete time system, that is a digital filter, and again it is converted back to the continuous time domain, and finally we will get the continuous time output. So you can see that the output is in continuous time domain. Now coming to the analog and digital systems. Analog systems are nothing but whose inputs and outputs are analog signals, right? A system whose inputs and outputs are analog signals like voltage or current are called analog systems, right? Here there is no conversion to digital values. The system will process this voltage or current using the analog devices and provide you the output in analog signals. Now coming to the digital, a system whose inputs and outputs are digital signals, right? What is the difference of digital signal and discrete time signals? We have already discussed, that is both sampling and quantization. Okay, both sampling and quantization is performed on a continuous time signal to obtain the digital signal. So if any system which perform operations on these digital signals are called digital systems. I hope it is clear.
Since the discrete time or digital signals have so many advantages compared to the continuous time or analog signals, for example, immune to noise or flexibility, reproducibility, and there are so many other parameters, many of the analog domain signals and systems are now very fastly moving to the digital signals and digital system implementations. That is why whenever we talk about digital, we think that there is some advancement happen to the existing system.